So if you just write down the link, bit.ly/1, O like the letter 3K7P7, that's where I've uploaded a lot of videos, my syllabus, all sorts of just resources on teaching. So there's a whole little Dropbox. It's about 1 gigabyte big. I'm only going to leave it up for about a week. So you should pull the materials down if you want them sooner rather than later, is my advice on that.
We'll email that link out to everybody if you didn't quite get it.
Okay, sounds good. And it's also at the end, Okay. So the first thing when I, lessons when I thought about what made the course successful, I think, is, and this, everyone knows this, but I'm just going to say it again, is to make it relevant. Make it relevant to their lives, make it relevant, bring up current science discussions, bring up, science in the media and various things, and that'll make them a lot more interested in hearing what you have to say. Also, astrobiology, great way to connect all the sciences, right? So connect all the sciences. Show them the process of science and how that happens. And also, in courses like this, I feel like this might be the last science course they ever take in their life. So take that seriously. And I think it's far less important that they learn astrobiology and instead that they learn the process of science and able to, skeptically look at, claims, pro and against things in the media when they're making their decisions. And I would say, the sky is a typo. Don't shy away from life lessons. Because again, this is your one chance to connect with these students, and you're a mentor to them. So don't shy away from talking about various things that they might find useful in addition to the science, which I'll talk about at the end. So the first thing with scientific literacy is I think you need to realize that most people have misconceptions way more basic than what you think. Way more basic. So, for example, 25% of Americans don't know that the Earth orbits the sun. And yes, I have interviewed one of these people. So I wasn't even aware that this was a common misconception until I did what's called an informational interview, which I highly recommend you do. You basically find a friend, or parent, or friend in a different field than you, and you just probe what they know about something. I was probing about the seasons and about the orbit of the sun, and I even gave the answer away to this person I was interviewing. I said, we know the Earth orbits the sun. Please draw for me what that looks like. And to his credit, he did not trust what I told him. He said, oh, no, I don't think the Earth orbits the sun. And I was like, oh, really? Tell me more. And he was like, I think the Earth is out here, and he drew this picture for me. It's great to have them draw pictures, because they actually have to think about it and kind of draw their schematic. So, you have some scrap paper. He drew the Earth here, and he's like, maybe goes a little to the left or to the right, but the year is caused by the rotation of the Earth. That was his, imagining of it. And furthermore, previously, about 20 minutes before that in the interview, when I had asked about the seasons, he drew the sun and the Earth down here with the northern hemisphere pointed towards the sun and the southern hemisphere here, and the Earth was rotating kind of on its top like that to describe the seasons. And so he had described the day, the Earth, the year, and the seasons all by the rotation. And it was just a very complicated rotation in his brain. So you need to know that. And then, 50% of Americans don't know that it takes a year to go around. So when you're in your classes, you need to descope and realize that your students might have these things. And even less understand the seasons or evolution. So I uploaded these 2 videos in the link. They're really good. I highly recommend about teaching methodology, but it's a private universe in Minds of Our Own. It's really great because it makes fun of Harvard students where they ask them to, graduating seniors to describe the seasons, and no one knows how to do it. And even physics majors, he's like, yeah, I took general relativity, blah, 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 and the seasons are this, and it was completely wrong. So I highly recommend, watching these videos and considering that you need to know what your students don't know or what they're misunderstanding before you can actually teach them. And so often as teachers, we think of students and children as these open vessels ready for our knowledge, but they're not. They have conceptions of how the world works, and they have experiences, and until you show them why their idea doesn't work for the seasons, they will never take in new information. That's like the big takeaway from those two videos. Yeah, and then also I think understanding the process of science is really good. For my course I used Robert Hazen's books, 2 of his books, and I think he really does a good job of showing like how are scientific processes, or how is science done? Like how is the question asked? What are the obstacles along the way? How does this lead to new questions? And to me, that's how I learned like the process of science, was just basically kind of reading historical science sort of vignettes. Again, similarly, but this is more of like a philosophical religious point, don't ignore what your students believe. So, you know, when people, I think this is actually the opposite of what I said here. Human beings as we know them today developed from earlier species. 48% that was true. There was a major political divide. Oh yeah, here. And then, but if you ask them, if you just change it, if you say according to the theory of evolution, so this is not about what I believe, but what does the theory say, then 71% say it's true. You know, according to the theory of evolution, human beings, as we know them today, developed from earlier species. And Republicans actually had a much higher percent of that being correct, though they had a lower percent of believing it was true. So they were more aware of what the correct theory is. So when you're teaching, you need to, again, show them why we think this. Why do we think evolution? Because otherwise, they'll answer the correct answer on the test, but they might not like actually take it to heart. And so the basic outline of my course is I decided you could teach astrobiology a whole number of ways because there's so many topics. But this is what I settled on, is I did half on prebiotic chemistry and half on finding life in the outer solar system on other planets. And I used these 2 books for the first part, The Story of Earth and Genesis by Robert Hazen. I really like them because of the process of science. And then for the second half, I used How to Find a Habitable Planet by Jim Casting. And then just like my own research, because that's what I'm interested in. And for the general course outline, I decided to do half of the course being activities, half of the course, you know, is discussions, debates, in-class labs sort of thing, and half the class was lectures. And the UW Astrobiology Activities Manual, which I uploaded to the Dropbox, has a huge array of activities already just ready for you. You don't even need to do the work. And we discussed, you know, other such articles in like Astrobiology Journal, like on the moral status of ET, and we did a reenactment of 2 famous debates, the Allen Hills meteorite debate and the Apex Chert debate, which I think is really great because the one guy who was anti on the one side was really on the defense on the other one in the exact same. I mean, he made the exact same mistake he was complaining about, so that's really good. And then, yeah, grading, I mean, this is boring. I had 2 papers and then an artistic timeline of Earth kind of project where they had to show the geological timescale and then cite and somehow artistically represent various time points of life's evolution. It was kind of fun. I also had weekly quizinos, like small little quizzes that take like 10 minutes over the reading, so they had to come to class having read it, like force them to come to class having read everything. And then I had a final group presentation on a sci-fi book where they analyzed the astrobiology, and that little thing is online. That was from Ty Robinson, actually, gave me that idea. But it was really fun, I must say. So what happened? Basically, the course went really well. The course got 4.97 out of 5 from 19 students as an average. And almost all commented on little life nuggets of wisdom part, which I included, which was about 5% of the total class time. So I spent between 20 and 40 minutes in 4 lectures throughout the entire semester talking about this. And this is what I talked about. Oh, here's actually some quotes from the reviews. I don't know if I can even create a full list. I feel like the class needs to be retitled Life on Earth Beyond and Little General Life Advice. What stuck with me the most was looking at science as a process, yay. You know, continually discovering and probing, disposing and refining of ideas with all the complications of human error due to paradigms and prejudices. I learned so much from the class, both about science and how to succeed, confidence, public speaking, etc. There are lots of little nuggets I will remember and apply to my life, such as power poses in the imposter syndrome. And you know, this one mentioned one of my other points, which was on females in science. So the lecture I gave on science and feminism was the best. Always made class interesting. Offered this course again, it was awesome. So I felt like this was, if I had to say what connected with students, it was this 5% of the class. You know, and this is like way out of the scope of what most science college classes do. And it was kind of a little mini experiment for me. And I was like, these are things I care about. I'm going to tie them in somehow to the point in the course that we're at. And it really resonated with all the students. And like out of the 19 reviews I got, almost, I don't know, like 16 to 18 of them mentioned something like this. So the first nugget I did was paradigms. And I tied this in with the debates when we were talking about the two debates, how the one guy could clearly see the faults in the other research, but then when it came to his own, could not see the exact same problems, which is just awesome. And I had them share examples with, of how they themselves had paradigm blocks. Does everyone know what a paradigm is? It's basically how, it comes back to this misconception idea, your worldview and your, what you think already influences what you can even perceive or see. You're just going to throw out data that disagrees with you, and you're going to readily take in data that agrees with you. And this happens to scientists, it happens to business people, it happens to politicians. I mean, it happens everywhere in life. And so we talked about this a lot in the class. And then I have, so the videos are, there's a video link at the end, which has one of these paradigm videos that you can like go online to their website and stream the whole thing. But the video itself is really expensive, so I didn't upload that. But you can find it on Interlibrary Loan. So. So yeah, right? We read what we have a preconceived idea of how English and words work, and we read them without actually reading them carefully. This happens in scientific data all the time. If you don't believe it, just wait. It'll happen to you. But also you can see about it when you look at historical science examples. This is the Hubble constant. Basically, this was taken from a course I TF'd at Harvard from that professor, but he said, always confident, never correct. And basically, everyone went around like, oh, this is, Hubble constant. Oh, yeah, so we'll get all values close to that. Oh, no, it's actually down here. Oh, okay, no, it's actually down here. Oh, yeah, it's all here. And so we tend to find values for data that fit with data that's already been published, even though maybe they could have had a better value earlier on. And so this is, again, just like a paradigm idea. Similarly, my advisor, Dimitar Saslov, when he first heard about the first exoplanet, so this was a hot Jupiter, a Jupiter that's a very big planet orbiting very close to the star. It had an orbit of 4 days. Previously, in planetary formation models, they thought Jupiters had to be like way out in the outer solar system where there was ice and dust, so at like 10 AU. So he saw this figure, he talked to the Michel Mayor, and Michel told him it's a 4-day orbit. And my advisor could not hear 4 days. Like, it was impossible for him to take in 4 days, because his idea of Jupiters was that they're far out. And so he heard 400 days. And he was like, 400 days, 400 days. And he talked to his wife that night. He's like, this is ridiculous. This can't be true. No Jupiter-sized planet could be at 400 days. That's way too close. That's near Earth's orbit. It needs to be even further out. And then imagine his surprise the next day when he was at the conference and it was driven home. No, this planet's super close to the star. And he was just like, how did I even miss that? I talked to the guy for 20 minutes. So then the second thing I talked about was why everyone should become a feminist. I have a whole bunch of women in science resources at this link, which again you can just see on the slides when you get it, and where I show about a lot of the peer-reviewed studies. So I'm interested in not necessarily just anecdotal stuff, but what is the data? And you probably are familiar with this study, but if you're not, it's fascinating / terrifying, where they had the same resume, but they just put different names, John and Jennifer, on it. They sent it out to physics, biology, and chemistry professors, and they had the professors rank the resumes based on hireability, competence, mentorability, and they gave them, the female, a 12% lower starting salary and ranked her lower on everything else, even though it's the exact same word-for-word resume. And this is in 2012. With, across the sciences, across from public and private universities, did not matter. The age of the professor evaluating it didn't matter. The tenure status didn't matter. The gender of the professor evaluating it didn't matter. We all have these biases. And so there's a whole bunch of other resources which I have online. But, we talked a bit about that, and specifically, it's brought up in Hazen's book, so I tied that in when we got to that part. The second, I don't know how I really tied this into the course, but I just think it's so important for young people to know, is the power of compound interest. i.e. open a Roth IRA. And I think I tied this into the funding of science somehow tangentially, but you should all have a Roth IRA if you don't, because of this table. Particularly, take a close look at investor A and investor B and see what the end result is based on when you invest money in a retirement account. I'm not going to go over this. This is something you can look at on the slides, but that was something I tied into my lectures, just as kind of like an FYI. You know, if you're over 18, you're almost already too late, so get going right as soon as possible. And the last thing, because they gave a public speaking presentation at the end, I tied in public speaking and presentation skills, and we watched this TED Talk, which if you haven't seen it, it's fantastic. It's Amy Cuddy's TED Talk on power poses. How many of you have seen it? Yeah, so like a third. Basically, in a nutshell, standing like this, 2 minutes before you give a presentation, like what I just did in the bathroom during the break before coming on, will lower your cortisol and raise your testosterone, which basically makes you come across as being more confident. And it's really, really fascinating research. They show even people who have been blind from birth, when they win at a physical competition, raise their hands up in this position, even if they've never seen it done before. And it's like cross-cultural, and this is basically just a simple way that you can influence your own body chemistry before a job interview. They did this in double-blind job interview studies. Preferentially, the people who did this power pose were chosen. So very interesting. And so we did that. Just general preparation for teaching. If you're astronomers, definitely, or physicists, mathematicians, anyone really can go to this, but it's particularly designed for astronomers. It's a CAE workshop. It's 2 days before every AAS event. I would definitely recommend taking a public speaking course. I would watch some of the videos I uploaded. I really like the Teaching Company's Origins of Life lectures by Hazen. That's how I kind of just learned, what about prebiotic chemistry? Because I don't know anything about prebiotic chemistry. And so that was a really useful course for me. And then I put the link here for that Paradigm video that's really expensive, but you can watch the whole thing for free online. It's like old. All these videos are older, but they're all so good. So I recommend all those. And then I put the link down here, and like I said, I'll leave it up for a week. And that is all.
Questions?
Yeah, Sarah, thank you. That was fantastic. The only thing I didn't catch is how you got involved in the first place in developing this course.
Yeah.
And so since you did it at Tufts, but you're at Harvard, how could we do that same kind of thing to teach those kind of courses?
Yeah, so I think, so the first point, how you can, I think universities love it to get like really low paid labor. So this course, for example, I get paid more being a teaching assistant at Harvard than I did for getting this course. I think for the whole semester was $3,000. I put way more effort than $3,000 into it because it's like you're the course head. But it was super impactful for me, so I recommend doing it. And I think so you can just ask your neighboring universities if kind of like you're an adjunct. You would just come in and teach this class. You can submit a proposal. I particularly did this through a program that Tufts has. So they have this program called the Experimental College where they particularly invite professionals and people with experience from around the community. So there were judges talking about Supreme Court cases or other sorts of classes that were timely and on topic. So I applied through that program and was accepted in through that program. And then my course was actually offered for credit at Tufts under the for natural sciences credit for their majors. Not all courses are, but so I think you can. I think basically, then there was maybe some conflict of interest. I'm being paid as a grad student, but I'm also giving some of my time to Tufts. So one of my professors mentioned that, but no one else cared, I guess. And so in the end, it didn't matter, and I just didn't say anything to anyone about it. But I think you can probably, most colleges don't have an astrobiology or origins of life class, so I think they'd be happy to offer it. And you can, and what I love about teaching your own course is you're not under a professor, you're not teaching Physics 101 where you really have to hit like all these different things. You can teach whatever you want, which is why I was able to put in 5% on other stuff. So.
Any other questions? All right, let's thank Sarah again.